Once you've bought into the fact that similar triangles are useful and that the ratios of their sides are so useful that you're going to give names to them so that you can have a shorthand way of talking about them and other people can understand what you're saying just by saying the name of the ratio. For example, sine, cosine, and tangent. Then it's good to get a little bank of basic examples that you can refer back to as you're figuring out more and more of what these trig ratios can do. So we're going to do that. The basic examples that we're going to look at come from two triangles. The first one is take an equilateral triangle. It has equal sides. You can choose any side you want, any length you want for those sides. I chose 2, just out of convenience. Cut that in half. I'm going to cut it in half from top to bottom. Then, if you think about just one of those triangles that it creates, so I'll reorient it so that this height comes down as the base. I'll also make the hypotenuse come up like this. The long side, the hypotenuse is 2. The short side, that's opposite from 30 degrees, will be half of 2, so that's 1. And then the side opposite from 60 degrees, you can figure out using the Pythagorean theorem. So if I call that x here, then what we know about x is that x squared plus 1 squared equals 2 squared. So x squared is 4 minus 1 is 3. So x is the square root of 3. Once I know that, then sine of 30 degrees, if I think about this triangle just being on an xy plane, then sine of 30 degrees will be y over r, so 1 over 2. And cosine of 30 degrees will be x over r, which is root 3 over 2. And then tangent will be 1 over root 3. You may want to rationalize the denominator here by multiplying the top and the bottom by root 3. That's the conventional way to write it, but I'm not going to do that here. All right. Once we've done this, we'll do 60 degrees as well. But I'm going to put 45 degrees in between them. And I'll think about that first. All right, to get the trig ratios for a 45, 45, 90 triangle, I again chose 2 for the hypotenuse out of convenience. But what I need to understand is that since these two angles are the same, these two sides will be the same. The sides opposite from those angles have to be equal. I'll call them both x. Then the Pythagorean theorem tells me x squared plus x squared is 2 squared. And if I have something plus itself, then I have 2 of those. Divide by 2. And then take the square root. So each of these sides is root 2. So sine of 45 degrees, if I think about this on an xy plane, sine of 45 degrees is y over 2. So this is actually my y in these definitions. Sine will be root 2 over 2. Because of the symmetry of this triangle, cosine is also going to be root 2 over 2. And then tangent is root 2 over root 2, which I'll just write as 1. And then last, I want to do it for 60 degrees. So I'll think about this triangle oriented this way on an XY plane. So I have a 2 for the hypotenuse, and I'm stopping here. So I have a 1 for the x value, and we had root 3 on the side corresponding to 60. So that's right here. So sine of 60 degrees is root 3 over 2. And cosine of 60 degrees is 1 over 2. And then tangent of 60 degrees is root 3 over 1. I'll just write that as root 3. Just knowing these basic numbers for these very simple examples will be really helpful when you're thinking about more theoretical ideas later that are more powerful. It's helpful to have some small basic examples to kind of ground your thinking so that you can think about whether a given hypothesis makes sense or not.